Good morning, Jeff.
Hello, hello. Good morning, good morning.
And good morning to everyone attending FIL Toronto. And fortunately, we cannot be here in person, so we're going to share our talk with you virtually. Let me introduce myself. I'm Bai Chao. You can call me Chao, and I'm VP at Origin Storage for North America region. I'm a crypto investor myself and a blockchain consultant since 2017. I worked more on the business side, and I also have Jeff with me today, who's our amazing blockchain engineer, works on the tech side. He has also worked on several private projects on multiple blockchain ecosystem. Very talented, and let's say hi again to Jeff.
Hello, hello, hello again. Yeah.
So let me give you guys a short intro of Origin Storage. It's next slide. Okay. So we're an all-in-one Filecoin mining service platform built for investors and SPs. We offer easy and affordable Filecoin mining hardwares and softwares. And as you can see here, we also offer node services, including IPFS, node establishment, node configuration, and node staking services. Next slide. We are also a storage provider. Our data center spreads across US, Canada, Singapore, Hong Kong, South Korea, and Japan. We are a very decentralized storage provider. And next. So today our topic is what's next for SPs after the launch of FVM. I attended FIL Austin, and the newest FVM launch date protocol lab release is this year in September. So very exciting, and we're gonna start by giving you guys an intro to what is FVM. I will have Jeff talk about this, and then we will talk about FVM use cases on deals which are gonna affect SPs, and of course also look at some other use cases which won't affect SPs directly, but might as well affect SPs indirectly because Filecoin price could change because of the launch of FVM. Right, so and I'll have Jeff take over from here.
Okay, so introduction to FVM. So let me give you a brief background on what FVM is. So the FVM stands for Filecoin Virtual Machine. So the Filecoin Virtual Machine is actually a WebAssembly-based polyglot execution environment for the interplanetary linked data. So it's actually designed to support the native Filecoin actors and written in different languages that are compiled to WebAssembly, as well as smart contracts written for foreign runtime, including Ethereum Virtual Machine, Secure ECMAScript, and the Berkeley packet filter. So the idea for FVM is that it actually proliferates the innovation solution in the user space. It gives programmers the ability to code whatever logic they want onto Filecoin and implement their own smart contracts. And in Filecoin FVM terms, it will be actors. And then it will also enable like a lower dependency on the system actor evolution. So features can be developed independently from one another. Like you can develop your own actor and he can develop his own actor, and we come together to build something even more complicated. So that's the idea of why Filecoin is implementing FVM also. Yeah, next slide. So this is like the rough architecture diagram of how the FVM look like. So we will have the foreign actor and the native actor on top, where you can see the right hand side is the foreign actor, the left hand side is the native actor. And then when people compile to, let's say, EVM bytecode, we can actually transpile. The design right now is to translate it into WebAssembly and then run that WebAssembly in the native Filecoin virtual machine, which is on the Filecoin node to execute whatever code there is there. Yeah. And next is the use cases for FVM, which I will pass back to my colleague Bai Qiao. Yeah.
Okay, so let's look at some use cases. We're gonna start with big data exchange. So here is a screenshot of the website for Big Data Exchange. Let's take a look. We're probably not gonna. Are you able to click on the link and share the website, or you're not? See if it's. If not, I'll just talk about it. Okay. Let's just look at this, but it's gonna look the same. You guys can check it out. I already put the website here. Is bigd.exchange. Big Data Exchange is a marketplace slash exchange where clients and storage provider meet. Clients are people who want to store their data, and SPs are us who provides data storage. And this marketplace will help with the price discovery because the storage provider are going to bid on it, and as a client you can see what's the price. Go to the next slide, please. Okay, the current implementation is on Polygon. It's not on FVM, but in the future it will move to FVM once it's ready. And how it works is very simple. Basically, if you want to store data, you contact a team to list your data on the exchange, and the team will list your data on the exchange with a smart contract, and SPs will bid on it, and then team will help hook up the SP with the client. Basically, it's just a brokerage platform using a Solidity smart contract. And as a client, you can manage and store data to the highest bidder, but the highest bidder may not be your desirable storage provider. In my opinion, SPs should aim to provide good quality services to client. For example, 24/7 customer service, zero incident, and etc. And client, on the other hand, should store their data with SP who has a solid reputation. Big Data Exchange or like similar marketplace, in my opinion, will have an unhealthy impact on both SPs and clients. People might flock to a Filecoin blockchain to store their data, their like so-called real data, just to earn rewards. So this example, like in my opinion, will have like a negative effect on us as SPs and also on clients. And going to the next use cases. Jeff, you want to talk about this one?
Sure. So the next use case is the multi-generational storage. I believe that the protocol labs has mentioned this a lot with FVM, one of the most well-known FVM use cases. So basically, it actually enable perpetual dues. This is quite similar to what a competing blockchain Arweave has right now, which is that when you store something, it persists on the blockchain forever. So in Filecoin, how it works is that it's through something called the storage bounty concept. So when user deposit their Filecoin for storage, to exchange for storage, a portion of the file will be reserved for future storages, and the current amount will be like allocated to the bounty, and then the bounty will be posted using, of course, the FVM smart contract, and SP can take up all these storage dues, and then the reserve file will be used for the future bounties. Because file is actually deflationary in nature, so the value of file will increase over time, and you will require less and less file for the future storage bounties. So it's sort of form a geometric series, an arithmetic series, whereby you will need less and less file to pay for your storage, and you will actually tend to just a fixed amount of file needed to store this amount of data perpetually. So this is basically how the multi-generational storage work in terms of the FVM smart contract. And this is actually quite similar to what we have on how they calculate perpetual storage on Arweave. They actually do some similar estimation to how much cryptocurrency is needed to pay for this amount of storage for the rest of the eternity. And then actually you can check out Jimpix, this observerhq.com at Jimpix to check out how the bounty code looks like. He has actually open sourced it.
Do you have this in the presentation? You can show the audience.
Okay, so the observablehq.com/@gympig, that link. Yeah, so this is actually a tutorial on how to code the FVM smart contract for the bounty deals. So it's actually written by this great contributor Jimpig. And then if you look through the code, you have all the explanation and details and a step-by-step guide on how to actually create this smart contract and the details of the logic. And then right now, there's another link, which is the lighthouse.storage. So this is actually a implementation that is completed and is a permanent storage for Filecoin. So it's done by this project Lighthouse. So you can actually
Can
visit
you
the
scroll down a little bit so we can see the website?
we can actually visit the website and check out on the details of how they do this. It'll be slightly different from the tutorial earlier because the tutorial earlier just exposed the logic of the storage bounty, and by building upon that, you can actually achieve the perpetual storage. So yeah, that's it for the multi-generational storage, and we can move on to the next use case.
Yeah, let's switch back to nice. Okay, next use case is, go to the next slide, is the big data NFT. This is a very exciting project. Big data NFT is a name like we created for now. We're not gonna know what's the future company is gonna name this. So this is an effective way for clients to monetize their data. And let's look at the next slide. We have a chart here. Yeah. So let's look at this chart. We have two parties in this chart. One is the storage provider and another is the NFT owner, right? When an NFT owner tries to retrieve the data from the storage provider will check against the registry contract, which is the contract on top, to see if an address has the right to retrieve the data. This is an authentication process. Only the owner of the NFT can retrieve data from the SP. So basically, the NFT is like a key to access the storage provider data, whatever like big data that is. And when NFT owner trade auction, the second part here, when the owners trade buy sell the NFT, the registry contract will also be updated accordingly. The registry contract is tightly related to the NFT contract in the bottom and can in fact be coupled as a single contract. But the main reason we separate these two is to achieve optimize the lookup. So we have lower gas fees and compatibility. The registry contract can also help in prevention of forgery in the big data NFTs by keep track of the CIDs. The CIDs here, which is the fingerprint of big data. We can also know if the data is an existing copy because each data has different CIDs. When a big data is stored on Filecoin, it's individually broken into pieces with unique CIDs. All this information can help us to identify if a data is a forged data or original copy. So here you see big data NFT. Big data NFT is the key, right? The key for you to access the big data. And the data, for example, we use data on every single human born on Earth after 20th century. So you can use the big data NFT to access this database. And here the NFT holders can trade or use the data. As NFT owners trade the big data, royalties can be paid to data creator and storage providers. And interestingly, the royalties can reflect the value of the data. The higher value of royalty you earn, meaning that data is traded frequently. Because by keep trading data, you constantly earning royalties, right? And this can generate perpetual passive income for both the SPs and creators. On the other hand, some useless data will suffer from lower trading volume and less royalties, which can also act as a signal to SPs to stop trading these profitable data. Another cool mechanism is if data creator sells multiple copies, they will drive down the cost of each NFTs. Since you sell 1,000 NFTs, then each access will be lower, right? Just like the Web2 companies. But it will also prevent data forgery as it becomes expensive to forge data. In the next slide, you can see here, let's go to the next slide. Yeah. Data forgery is a very important issue we need to conquer. We need to prevent data forgery and ensure the data integrity. And data forgery refers to uploading similar identical data and selling them as NFTs. For example, you have the NFT, big data NFT, and you use it to access a database. After you access it, you have duplicated the data and make it into a new big data NFT. So we need to ensure that the cost of forgery is actually more expensive than the revenue of forgery. This can be achieved through the NFT mechanism. If the creator mints multiple copies of an NFT, there is a larger supply out there and a lower floor price, which means the forger will need to have an even lower, even lower floor price for the forgery to sell out and profit. Data forgery on Filecoin is not trivial. Data is always partitioned into sectors on Filecoin chain, so there can be significant overhead processing costs to fetch and duplicate these data. Another aspect that deter data forgery would be gatekeeping performed by us as SPs. SPs will ensure and check the data content before minting the big data NFTs. If the SPs found out, oh, this is a forgery data, then, or is already existing in our database, then we can refuse and prevent the NFTs from minting into existence. We'll also be adding a verified logo to the big data NFTs that are verified by our partner SPs. So in this case, SPs need to work together so we can both scan the data clients use to make the big data NFT. Right, and we will authorize and put a logo there, say, oh, this one we have already authorized. This is the original copy. Data integrity is also ensured by the SPs. The SPs will take a look at the content of the big data and determine whether the data is valuable enough to be an NFT. Again, this will be added to the verified logo, and I have a photo, I have a display in the next slide, I think. Can we go to the next slide? Yeah, see here. So users will see the verified logo when viewing it on the big data NFT marketplace. So they know this is the original copy. Okay. And this project it's like very interesting, and I think there are lots of potentials for SPs, which is like a good impact on SP for sure. And let's go to the next. Next are some other use cases for FVMs. They are not relevant to the to data deals, but they can also affect Filecoin price, and that will affect SP as well. And I'll have Tom talk about these projects. Not Tom, Jeff, sorry. I sometimes call you Tom, sometimes call you Jeff. Like his name is Tom on Discord and all other like social media. So forgive me on this.
Yeah, it's okay. Yeah. Okay, let me talk about one of the most common use case for FVM, and that will be actually decentralized finance. So because we can easily port existing decentralized finance smart contract onto FVM. So for example, we can have AMM like Uniswap, we can have oracles, and then we can have lending protocols. All of these different DeFi protocols can be actually implemented on Filecoin. But we need to understand that there's no incentive for users to create such DeFi economy on Filecoin ecosystem, because we already have existing ecosystem like Ethereum, Binance Smart Chain, Polygon, Solana, which already has very mature DeFi ecosystem. So ultimately, Filecoin should do what it is best at, which is for data deals. But this kind of if people do implement decentralized finance on Filecoin, which people will definitely do that, it will have some spillover effect onto how the Filecoin itself is, how File is priced, and that might affect how our data deal is priced subsequently. So the next slide will actually talk about other potential use cases. So like, for example, FileSwan's multi-chain storage, which is actually it's a cross-chain storage solution. So user actually pay in their native blockchain currency to store their data on Filecoin. So example, if you are running you are using Polygon and you want to store some data and pay on Polygon, you can do that, and your storage will be magically stored onto Filecoin. So the logic behind this is that they use oracles like Chainlink to verify that on Filecoin, the data is actually stored. And then what they do is that they have a sort of a data DAO, and everyone will check and then sign if they've actually verified that the data is actually stored, the deal is completed. And when a threshold signature is met, then on the Polygon side, the Chainlink will send the data over there and then release the escrow fund to the person who stored the data. So all of this logic can actually be done using smart contract for the Filecoin side on how to actually distribute these deals. So distribution of these deals can be done by the smart contract, and SP can bid on the different price of data deals. So depending on the demand for cross-chain storage solutions, we can actually see a sort of like a spillover effect, and also similar to what we have for DeFi, perhaps an increase for demand in File and the Filecoin price. Yeah. And that's basically it for some example or other use cases for Filecoin virtual machine. Of course, there are many more use cases that we have not covered here, but yeah, due to time constraint, we will just cover until here.
Thank you, Jeff. And thank you all for joining us at this session. I hope you all have enjoyed FIL Toronto so far. This is already the third day, I believe. Because of, like Jeff said, because of the time restriction. If you would like to discuss more or interested in our product and services, please email me, or you can add me on LinkedIn by Chao Ren. And this is my email address here. And thank you all. That's it. Hopefully we can be in person with you guys next year. Bye.